My name's Alex Moffat, and this is Damon Lundin. We're from Lombardi Software in Austin, Texas, and we're going to talk about using the Google Web Toolkit to build a high-performance collaborative diagramming tool. We're going to use as an example, of course, the tool that we built, which is Lombardi Blueprint. Now, I'm going to start by talking about collaboration. Then Damon's going to deal with the high-performance aspects. And finally, we'll end with some GWT tips that we've sort of accumulated over time. I'd like to start, actually, with a quick demo of Blueprint. So if I now switch over here. And before we sort of get started, I need to say a few words about what Blueprint actually is. It is a business process diagramming tool, and it's designed for business users. And this is sort of important because this really informs the set of features that we have and the set of features that we don't have, and a lot of the way that we've implemented things. So we expect that our users are experts in the business and understand the processes that they're going to be documenting. They are familiar with tools like Word and PowerPoint. An awful lot of diagramming gets done in PowerPoint, but they are not necessarily power users or technical users. So the first thing I'm going to do is actually go ahead and create a new process. I need a process, for example. I'm going to use the process of creating or submitting a talk for a conference. So I go ahead and say this is going to be demo. And let's put this in this project here. And this is the first screen, and this shows you on the right-hand side what we call the map area, and on the left-hand side the outline. And the first thing to do is to come up with some sort of ideas of what the activities actually are in this. So I think if we're going to do a presentation, we need some ideas. We need an abstract. As you see, as I add stuff to the outline, it sort of flies into the map. We need some slides. We probably need to rehearse. Travel. Equipment, possibly. Bios, get some feedback. And at this point here, we've got sort of some list of stuff we might want to do, and we can now start to arrange this. So we say we've got a submission phase, and that's probably where we come up with the ideas. Ooh, get this mouse to drag. And where we produce the abstract. I think we should probably have a phase where we do so actually prep, and that may be where we do the slides, and we do the rehearsal. And now I can see up here that actually Damon is online as well. So this is the collaboration part of it. I can see who else is logged on. And I'm going to ask him to join here and help me fill out the rest of this stuff. So I'll just send him a link to this page. Okay. So now we should get a message saying that Damon is viewing this page in a second. Meanwhile, I will go ahead and say that we actually probably right. I think we need to do a demo. Let's have a demo. Actually, I want to move the prep up here first of all. And I think I want to do the submission part before I do the prep part. And let's put the travel bit back here at the end. So as you can see, Damon's actually able to make changes to this thing while I'm making changes to it. There's no need to go ahead and sort of, pass a document from one person to the other. We can both simultaneously do different things to the same process at the same time. Okay, so perform the demo is actually not part of that. Perform the demo is part of something else. So, and actually one extra thing here, we do have undo. So we have undo, I can do that. And then, of course, I can undo that like that. So basically, that's the collaborative aspects of this. It's our demo. And here are a few quick numbers to give you some idea of the size of this thing. So this is an app that we actually sell to people, and people have actually paid money for it. We have a fair number of customers. This is sort of the third version of this application. We built an initial one that used HTML and Flash, and then did a sort of an alpha release that was all rewritten using Dojo, the Dojo JavaScript toolkit. And then at the beginning of 2007, we moved over to GWT and redid the whole thing in GWT. So we've had like 2.5 to 3 people for 1.5 years to get to where we are now. That 37,000 lines of Java code does not count white space, comments, or single braces. If you include all that crap, it's like 76,000 lines. It's a fairly big application. And we had, on the collaboration side, four main goals. So we wanted mutual visibility of changes. As you can see, if I make a change and Damon makes a change, I want to see what he's done, and he needs to be able to see what I've done. Secondly, we wanted no locking. We didn't want to build like an online analog of passing a Word document around. We should both be able to make changes to the same process at the same time. Though the product is built for collaboration, so for people working together, it can occur that you're both going to end up making conflicted changes. And we wanted to have a reasonable policy for that. And basically what we do is we keep both changes and display them to the user and let the user decide what to do. And finally, we don't assume, and in fact we can't assume, that our users are familiar with source control. So we don't build an online analog of CVS or Subversion or Perforce or something like that. And to achieve this, the client runs in a browser, of course, and we have a very conventional model view controller in the browser, where the controller is actually implemented as a series of commands, which we'll talk about more later. The model holds only the data needed for the page that's currently being displayed. So there's actually more data on the server. And the view, of course, reflects changes to the model back to the user. So, if you do user interaction like drag and drop, that creates and executes a command object which modifies the model, and then those changes to the model are shown to the user. On the server side, we have another model that we call the repository that holds all of the data for an account. So users live inside accounts, and there's no visibility across accounts. And that thing is backed by a database. And then on the client, we've got a remoting component. So changes to the model go through the remoting component and are pushed across to the server. Now, if you've got other people in other browsers that are observing the same process, we can't go ahead and send them the whole model every time there's a change. So someone makes a change on the model in their browser, and that's reflected in the server. We can't go ahead and propagate the entire model across to everyone else. We need to be able to send only the changes. What happens is that each browser that's viewing the same process or the same, what we call slice of data, asks the server and says, hey, I'm looking at the version effectively as of, 3:30 in the afternoon. Can you tell me what changes there are between the version that I have and what the latest version that you have is? That's sent back to each of the other browsers, and the remoting component then applies that to the model, and it's reflected in the view as normal. So from the point of view of the programmers working on the MVC portion, you don't actually have to worry about the communication with the server or the fact that other people are maybe making changes to the model on the server at the same time. To make this work, we need to be able to, on the server side, find out what the state of the data is at any point in time, going backwards in time. And to do this, we store everything as dated collections of property values. And I'm going to illustrate that with a simple example, which is I will try and represent Mary had a little lamb using our repository model. And it's pretty simple. We've got two items, two objects, one that represents Mary and one that represents the lamb. So we've got item 21 is Mary, item 25 is the lamb. Mary has got three properties, a type, a name, and this header property. And the lamb has got two, the type and the size. We also have two additional columns for everything. The live start, which is the earliest date at which this value is valid, and the live end, which is the latest date at which this value is valid. And null just means that it's valid now. Now we're going to imagine that, of course, the lamb gets bigger. So at 10 o'clock, it's going to be a large lamb. And all we have to do for that is to write a live end value in of 10, so that the size of little was valid from 9:50 to 10 o'clock. And we now have a new value of large, which is valid from 10 o'clock onwards. We can do the same for the header property. I mean, if she loses the lamb at 2 o'clock in the afternoon, we just end date that row. And now if we look at the table after 2 o'clock, we no longer see that had a property. So we just see basically Mary. Updates to the repository are done at that property level. So fundamentally, what you have to do is you have to modify property value rows. You do things like, I want to add a new property value to this object. I want to create a new object. I want to move this property value from this object to this other object. And you create a list of property value changes you want to make, and you apply them atomically to create a new version on the server. So basically, a version is, here is the list of changes that have been applied to this version, and that gives you the new version. The other thing the repository has to be able to do is to compare two different versions. So we can take the version as of 9:50 and compare it with the version as of 2 o'clock and return what are the changes needed to convert from the 9:50 version into the 2 o'clock version. And that's how the client finds out what changes it needs to apply. It basically says, I have the data as of 1 o'clock. Tell me what changes have happened between 1 o'clock and like 1:10, and it gets back a list of changes and it just applies them to the model. On the client, of course, we'd prefer to work at a higher level than the property value changes. So we actually generate a sort of layer of convenience classes over the client model, which let us use getters and setters and add property change listers and all that sort of stuff. This is just to make our life easier, because when you're programming, you'd like it to be as simple as possible because we have to actually maintain this stuff. Now, as a single UI interaction can involve many modifications to the model, and we want to make sure that we collect all the modifications together and apply them atomically on the server. And we do this using these commands. So we can mark the start and the end, so the boundaries of the actual action. And as long as we handle nesting so that you can call a command from within a command, we're able to say this set of property value changes represent this user interaction and should be applied to create the new version on the server. Of course, because on the client we can actually record that. That's how we do undo. I mean, all you have to do is record this is the set of property value changes that were applied. And as long as you can reverse them, you can just roll back. So all we do is we record all the lists of property value changes and apply them in reverse order to do undo. The final portion of this side is the communication with the server. So as you saw, there is no save button. As you make changes on the client, we send the data across to the server on a fairly frequent basis. We do it sort of from a deferred command or from a timer, so that we don't interfere with people actually doing work, and also so that we can accumulate a complete set of changes before we send it over. We don't want to send like a partial change. And each client, in order to find out what changes it needs to apply to get back into sync with what's on the server, we use polling. So we are asking the server on a fairly frequent basis, hey, are there any changes between where I am now and what you currently have as the tip version, the most recent version? We tried initially to use continuations, so we're actually using Jetty as our server because it had this nice continuation feature that let us hold open a connection, and we could have a long-lived connection. We send the request over, and then all we have to do is we hold that open for 2 minutes, and if there's nothing happening, we're not polling all the time. The problem is that 2 connection limit from the browser to the server. Once you're holding one open for like a long-lived connection, and then you go and ask for an image, and it takes a while for that to come back, well, I'm sorry, that's really delaying your other RPC calls. Or you make an RPC call, and now you can't download this image, or you can't download this CSS. We were finding the whole thing was starting to stutter badly, so we actually went back to just polling. And we've not had any performance issues with that yet. So at this point, actually, having rapidly covered that, I'm going to turn over to Damon, who is going to talk about diagramming.
So I'm going to shift directions a little bit and talk a little bit about performance. And to do that, I'm going to show you the most performance-demanding feature in our application, and that's going to be our diagram. Here, Alex has been showing you the map view of Blueprint. This is sort of the high-level view that our business users are most likely going to be interested in. This just shows you some of the activities and the sub-activities that may be involved in whatever process it is that they're creating. In addition to this, we have another view, which is basically just another view on the same set of data that we call a diagram. And this diagram is going to allow us to delve into further amounts of detail than we could on that previous map. So in this case, we may add a decision to decide, was our talk accepted? If not, perhaps we're going to evaluate. And then maybe we want to try again next year and go back to the beginning. We can also add swim lanes. A swim lane represents a person performing some particular action. So let's say we got Alex and me. We can drag our items into other swim lanes to represent someone's going to perform that action. We can also drop items on top of other items. We can move them to other lines. And I'm just going to make a mess here to show you that we can fill this out into more detail. Here we have collapsible subprocesses so that the user can decide what level of detail they want to see on these particular diagrams. Now, for those of you who are thinking to yourself, we've implemented Visio on the web. What's so big about that? Well, there's one very important feature that is of a lot of benefit to the business users who are using our application, and that is that Blueprint has a very sophisticated positioning and routing algorithm involved. As you saw me sitting here dragging these various items around and inserting things, that I didn't have to worry about where I was going to put everything. Blueprint basically did all that work for me. So it removes the temptation from the user to spend countless hours fiddling with their lines and fiddling with all of their individual objects. Blueprint basically does all of that work for you. Now, we do have the ability for the user to change some of that. So, for example, I can take activities and I can position them on top of other ones. Except that one didn't actually work. So we can do vertical things like that. So there's a very limited set of things that the user can do. But for the most part, Blueprint is going to take care of that work for us. So what this means is that we have a fairly computationally complex application here. And what that means for us is that we don't have a lot of extra CPU cycles or computational cycles that we can spend doing interesting things like handling user events or dealing with other user interaction. Unfortunately for us, there's also another significant constraint, and that is many of our users are corporate business users, where they have little or no control over their own computers. They can't install software, they can't install plugins or anything like that, and many of them are still running on IE6. And unfortunately, the JavaScript engine in IE6 doesn't perform very well. But because we want users to be able to get onto Blueprint and start working very quickly without having to install anything, even if they can, we need to program sort of to that lowest common denominator. So we needed to come up with a diagram that would be able to function even under IE6. And IE6 is what we're using here. To show you some of the scale that we're talking about, I'm going to insert a link to another process that we've already created, and I'm going to open that process up here. This process is going to open up into a much larger process that's going to be more complicated, that'll give you an idea of some of the scale of some of the types of processes that we can create in Blueprint. So here we've got something that has lots of subprocesses, lots of lines that cross over the whole diagram, and we were able to draw it in somewhat of a reasonable time. Now, some of you may be thinking that that was a little slow, and it would be if that's how long it was going to take the user to continue making changes to this diagram. Now, I've got an ace up my sleeve, and I'm going to explain how we deal with that later in the talk. Now, what you see here is not the first implementation of this that we had. We actually have a previous implementation that we put into production, and it performed okay for small diagrams, but unfortunately, people started to use our product more, they started creating larger diagrams, and it didn't scale very well. So I'm going to explain the nuts and bolts of exactly how that works, what the problems were, and how we overcame them. So here you see a typical example of how a lot of us are familiar with building in Swing, Eclipse, typical MVC patterns. This is sort of the selling point of GWT. This is a pattern that's very familiar to most of us and probably most of the people in the room. The way that this works is typically we're going to go through our entire diagram, and for each one of those individual items, we're going to create a widget for it. That widget is going to be a complex widget. It's not going to be just one thing. There's going to be other widgets inside of it. In this case, we have a flow panel. We've got a text box. We've got image. We could have a bunch of other things inside of it. It's going to be a complicated object. We're also probably going to want to add listeners to that widget. We're going to add a bunch of listeners. Sometimes you may be creating new listeners. You may reuse them. But in this case, we're still adding listeners to each one of our widgets. And then when we're finished, we end up stuffing it into the root, and it becomes part of the application. Well, unfortunately, in some cases, this design is relatively heavy. Every time you create one of those widgets and every one of those nested components inside of that, GWT is constructing a JavaScript object that represents each one of those Java objects. Well, unfortunately, JavaScript object creation is particularly expensive, especially in IE6. And not just creation, but also garbage collection. So unfortunately for us, when we got into the scale of large diagrams, this particular design didn't work very well because we were creating lots of these JavaScript objects, multiple listener objects. We, unfortunately, at the time, weren't even reusing listener objects. Now, the GWT listeners, since they passed the widget that generated the event back to it, you can actually reuse them, and that's something I suggest you do if you are using regular GWT widgets. In any case, it still required us to attach listeners to all of our individual objects. Now, before any of you freak out and think I'm completely dissing GWT, because this is basically the highest selling point of GWT. It allows you to write in Java using a pattern you're very familiar with. Well, I want to step back and point out that this design that I've talked about here, we use it for almost our entire application. Almost our entire application, including that original map that Alex was doing a demo of, uses this simple pattern. We've got GWT widgets and listeners, and we're building all of that in this pattern, and that works perfectly fine. But at some point, it doesn't scale. In the case of our diagram, we have all of those algorithms that suck up a lot of CPU cycles, and we just don't have the bandwidth to deal with it. So how did we deal with this? Well, when we set out to come up with a new implementation, our most important goal was to increase the responsiveness of our application. We wanted to make sure that when the user does something, if they draw a line or they insert an activity or they do something like that, the application is going to respond as quickly as possible. Well, part of the problem is that every time the user does one of those things, we have to regenerate the layout for that diagram. And we want to make sure that that response is as quickly as possible. So getting that visual aspect to the user and setting aside anything else, such as doing all of that event handling, creating event listeners, all of those things, those aren't strictly necessary to getting that result to the user. We want to make sure that we do that as quickly as possible. So in the end, I concluded that the only way that we could do that fast was to, unfortunately, go back to regress to a former style of programming, and that was instead of using the widgets and the pattern that I just showed you, we're just going to create raw HTML. And I'm going to show you that in a little more detail in a second. In addition, instead of creating individual listener objects for all of our items, instead of having those widgets and attaching listeners to them and using each one of those widgets, we're going to make use of a flyweight pattern. So instead of constructing a widget for every one of our items, we're going to construct an object for every type of item, which is fixed. In our case, we've got 12 types of items, so that means we're fixed at 24 objects that we're going to create. We're going to have one for doing event handling, and we're going to have one for rendering HTML. And that's going to save us significantly over that JavaScript object creation where we could be creating hundreds or thousands of objects. And then finally, instead of attaching listeners to all of our individual items, even if we're reusing that, we're going to go to a pattern that uses a single listener instead. So this is how the rendering works. Now, this probably looks pretty familiar to you. This probably looks like servlet code. But I want to remind you, this is actually running in GWT on the client. We start off by creating a string buffer. We're going to iterate over each one of the items that we have to display, and we're going to ask one of our particular renders to generate HTML for that particular item. And if you see down here at the bottom, we've got something that probably looks very familiar. We're just going to append to our string buffer a bunch of HTML. We're going to insert the dynamic content, such as the ID of the item, its position, any other information that's necessary to draw that item. Once we have the HTML for all the items on the diagram, we're just going to stuff them right into the DOM. And then the browser is going to take all of that HTML and show it to the user. This is the fastest way to generate dynamic content on the client. Now, so how do we do event handling with this? So far, all we've done is we've done some HTML. and we haven't attached any events. We haven't done anything like that. So here's an example of some of the HTML that we might generate from our application. We've got 2 items here. They're not necessarily going to be simple items, just like the widgets that we had before, which were complex nested widgets. We may have a bunch of nested elements. So in this case, we've got 2 divs that represent the root level item for each of our items, and they're going to have tables and divs and images and other things buried inside them. So let's see what happens when the user clicks on an item. When the user does that, the browser is going to generate an event on that innermost item that the user clicked on. Since we haven't done anything as far as events are concerned, we haven't attached any events to any of these particular elements, the browser is going to bubble that event up through the DOM hierarchy until it gets to the top. And what we're going to do is we're going to put an event up there in that top level item. And that's how this works. So here we have basically one of our only widgets in the diagram. This is going to be a diagram widget. This command up here is the command that attaches that listener to that top level element. So this is the only place that we're going to set up a listener for that entire diagram. By doing this, we've enabled the events for that diagram. Every time an event occurs, this method on browser event gets called. And the first thing that we're going to do is we're going to look at that particular event. Now, fortunately, the browser was kind enough to tell us what exactly it was that the user clicked on. In this case, it's going to be that innermost div. Now, we don't really want to know what that innermost div, innermost element was. We want to know what the div at the top was. We want to know what item it was that the user clicked on. So what we're going to do is we're going to start from that innermost div, and we're going to walk back up the tree until we find an element that has an ID attribute set on it. As soon as we find that element, we know that we've gotten to that top element that represents that particular item, and once we've done that, we have the ID for the item, and we know all the things that we need to know about that item. Once we have its ID, we can figure out its type. We can get one of those flyweight handlers that I mentioned earlier, and then we just dispatch that event and forward the original event as well as the ID off to this particular handler. So then that handler knows which item it was the user clicked on, and it knows what type of item it was so that it can respond in a particular way to whatever that item was. Now, unfortunately, there are some problems with this. At this point, all we have is HTML. So that works for the simple case. Say mouse over. Say you move your mouse across the screen and you want to highlight a particular element as you move your mouse over it. Well, all I need to know is what element it was the user moved the mouse over. Well, what if they've clicked on an element and they're now dragging it across the screen? We want to know not just what element it is that the user is dragging. We also want to know what other elements are underneath of it, or what elements may be close to it, because we want to find possible drop targets. We want to know where is it that we could possibly drop this particular element. Now, in our previous implementation where we had widgets, we could simply go through all of our widgets and ask them, are you a valid drop target? And they could say yes or no. But we don't have those widgets anymore. All we have is HTML. So really what we want to do is we want to try and get back some of what we lost when we got rid of those widgets. We want to get some of these more useful data structures back. Well, fortunately, all of that information is actually stored in the DOM. All the various objects, their positions, it's all stored right there in the DOM. So we can simply look at the DOM to get that information. But I want to go back to that goal number 1 that I had before, where we want to make sure that we get the response to the user as quickly as possible. So we want to make sure that creating these data structures and doing any of this work doesn't slow that down. So what we're going to do is we're going to render that HTML, and then later, after that is shown to the user, only then are we going to create these data structures. And once we have those, we can do more interesting things like arrange them into bounding boxes, so I don't have to search the entire diagram looking for possible drop targets. And that's going to get us back some of the things that we lost from those widgets that we had before, except now instead of having multiple JavaScript objects for each one of our items, we're just going to have one simple data structure. And this is a little bit of how that works. So we start off here. We've generated a bunch of HTML, and we put it into the DOM. The very next thing we're going to do is we're going to execute a deferred command. This gives the browser the opportunity to breathe. What it's going to do is it's going to allow the UI to actually render that HTML and show it to the user. Only after the browser is finished with that is it's going to call this create cache function that's in this deferred command. When we do that, like I said, all of the information that we need to know is encoded right there in the DOM. We're going to just walk through the DOM. We parse out the ID, the positions, any other information that we might need to know. We pull it right out of the DOM, and we construct whatever our useful data structures are and organize them however we need. Now, let's say like you've done all of these things. You've got your application going as fast as possible. You're generating HTML. You're using a flyweight, single listener, and it's not good enough. So in that case of that large diagram when I opened, that still really is a little bit too slow. But sometimes users can also create very large diagrams. Sometimes it's not just about how many things you have. In our case, we have this complicated algorithm. Maybe a user draws a line that our routing algorithm can't evaluate in a timely fashion. Well, so what do you do then? Well, fortunately, there is something unique to GWT that we can't get from anything else. We can dual compile our code into both Java and JavaScript. If the client is too slow, run it on the server. You're going to find that the Java VM is much faster than the JavaScript engine, particularly in IE6. We find that the difference can range anywhere from 10 to 100 times faster running in the Java VM. So now we need to decide, are we going to run on the client, or are we going to run on the server? How are we going to do that? Well, we argued about a number of different algorithms that you can use. We can try and predict how long it's going to take. We can try and measure network latency and bandwidth to estimate the server cost. But we decided in the end to just come up with a simple algorithm. So the way our algorithm works is the first time the user opens up a diagram, we're going to draw it on the client. That could potentially be slow, some like that first diagram that I opened up for you. At that point, we're going to know whether or not the client is fast or not. If it is fast, great. We're going to continue to build those diagrams on the client. Well, if it's too slow under, say, a certain threshold, in our case, 2 seconds, if that diagram won't render fast enough, well, the next time, we're going to do it on the server. Now, we don't know what the bandwidth and latency may be. We know that it'll execute on the server very quickly. So we're going to measure the total amount of time it takes to generate that request and get the response back from the server. Once we know that, we know how fast the client is. We know how fast it takes to get a response from the server. And from then on out, we're simply going to pick whichever one of those is fast. And we actually keep a running average so that if one of them starts to get slow over the other, then we can just switch back and forth. In our case, the interface is pretty simple. When we want to make a server call, we simply use GWT to execute an RPC call. The interface is really pretty simple. In our case, it's almost entirely HTML. So we make a request to the server, say generate a diagram for this particular process, and it just sends us back a whole pile of HTML. Now, fortunately, because of that create cache function that I showed you a minute ago, we already have the ability to get all the information we need right out of HTML. So this pattern fits into that pretty well. I was going to show you a demo on just how effectively this works. So I'm going to go back to our diagram. And I've got a little debug parameter I'm going to add up onto our URL. And what this is going to do is it's going to show us a little more information about what's going on. So when I refresh the page, that causes the GWT module to reload. So this is effectively like we come to the first layout of the page. Now, for those of you that, I don't know if you can all see that, that says client layout, 6,296 milliseconds. So that's a little over 6 seconds. That's definitely over that 2-second threshold that we had. And it's really not at all responsive. So if the user has to sit down and start messing with this particular diagram, if they start inserting things, and it takes 6 seconds every time we do something, well, they're probably going to get frustrated and not want to use our product. So let's see what happens when I actually add something here. Server layout, 1,783 milliseconds. Let's try another one. 911 milliseconds. Undo. 721 milliseconds. It's almost 10 times faster. In this particular case, the server is running on this particular machine. We didn't want to be at the mercy of Moscone's network connection. In production, our servers are much faster than this laptop isn't particularly fast. Of course, that's going to be offset somewhat by the fact that there's going to be additional latency and bandwidth considerations to take into account. But basically, this sort of allows us to deal with those few cases where we really can't do it fast enough on the client. GWT gives us the ability to take the exact same code that's running on the client and run it on the server instead. And we only have to do it in those cases where it comes out to be too slow. So lastly, I have a handful of slides. These are just sort of miscellaneous things that we've learned as we've developed through GWT. Unfortunately, I think these first 2 points are made somewhat, they may be completely eliminated by Bruce's announcement today of GWT 1.5, but we'll see. The first one is sync events. Now, you're not likely to use this yourself very often. It's somewhat of an internal component of GWT, but if you're operating directly against DOM elements instead of GWT widgets, you may find yourself using this method. Unfortunately, this method is rather slow. There's a couple reasons for that. I won't get into too much detail, but the implementation wasn't done as efficiently as it could have been, and it's also called too often. You may be calling it too often yourself if you are operating directly against the DOM elements. In GWT, it's actually called in the constructor of a lot of the widgets, which means it gets called even if you don't need any listeners on a particular element. Both of those have been addressed in 1.5, and I'm eager to see just what improvement we'll get. Now, it's still not going to be the most fast thing that you can call, and so if you find yourself calling this frequently, you should consider using a pattern that I've mentioned here, which only has a single event. The next thing I want to mention, if there are any Google GWT developers in here, they'll probably want to stone me for this, but I'm going to say it anyway. Consider using the fast string map. This class is a class that's part of the Google API. It's a package-protected class, and the Google folks have declined to make it public. This was a particularly big problem in GWT 1.3, and they've gotten much better in 1.4. But if you use a hash map or a set that has string keys, that's going to be relatively slow. And what we found is using the fast string map, which is basically nothing more than a wrapper around a native JavaScript object, is much faster. Now, if you do this, you want to make sure that you use the class directly and not through the map interface. The map interface exposes the object, the put and get methods that take object keys, whereas the fast string map itself has string versions of those methods. Now, when you call the object versions, it basically does a type check to make sure that you actually passed it a string because that's all it can handle. If you call the methods directly, you basically avoid that type check, and that's where all the performance is lost. Hopefully in 1.5, now that we've got generics, you can actually say that you've got a hash maps with strings, and hopefully the GWT folks have picked the fastest implementation for those cases, but we'll see. The next one is put as many of your style constants as you can in CSS. If you find yourself calling setStyleAttribute a lot with a value that doesn't change, don't do that, because DOM operations are relatively slow. You should try and put those elements in CSS, and the browser can handle those pretty efficiently. Avoid using iterators over a list. When you call list.iterator, that constructs a new JavaScript object so it can return you that iterator. If you iterate over the list using index instead, you basically save yourself the creation of a JavaScript object. And as I mentioned before, JavaScript object creation is relatively expensive. So try avoid doing this. Another thing that you can consider doing is putting JSON directly in your web page. So as you can see, some of our processes can contain a lot of data. The first time the user goes to one of those particular pages and it opens up that process, we want to be able to show that as quickly as possible. Now, one of the tendencies that you may have as a GWT developer is to return an empty HTML page from the server and then make a second RPC call to actually fetch the data that you need. Well, that's just going to create another round-trip call to the server that you don't really need to make. All the information that you need, you can embed it right in your HTML page using JSON. You just define a JavaScript variable and have your server just pile in a whole bunch of JavaScript. The next point is probably not one that is common to too many people, but if you're writing an application that generates lots of lines, one of the common techniques is to use a bunch of divs and put borders on them. Well, we found that that's relatively slow. Since we have particular performance problems with IE6, Microsoft has a vector graphics library called VML, which is basically their version of SVG. And so we're using that for IE, and we find that to be much faster. We could use SVG for Firefox, but since we don't have performance problems there, we're not using it. And then lastly, I have a couple of tips for the folks out there who are developing in GWT. Some of you may have the experience of firing up hosted mode, attaching a debugger to it, setting a breakpoint, and then going in to examine a particular variable, only to find out that it's a native JavaScript object, and it says opaque. And it doesn't give you any information about what's inside of it. I don't know if they've addressed this in 1.5 or not. But one of the things that we did is most of the native JavaScript objects that we use in our application are wrapped by a custom Java object that we've created. Simply put a toString method on that and call native accessors, and that can pull information out of that. And your IDE can call that and give you more information. Makes it much easier to see what it is you're talking about while you're debugging. We've also heard a lot of people complain about compile time. It got better in 1.4. We'll see how 1.5 is. But there's a couple of things that you can do to significantly improve your compile time. The first is, by default, GWT compiles your Java into JavaScript for each one of the browsers it supports. And I think there's about 6 or 7 of those different browsers. Now, when you're actively doing development and you're frequently recompiling, you probably only need to be using one browser. So what you can do is you can set a user agent property in one of your configuration files to tell GWT only compile for this one particular browser. And that's going to tremendously speed up your compile time. Another thing that you can do is make sure your application is divided into modules. In Blueprint, we've got different modules for each one of those tabs that we have at the top screen. Whenever I make a change to a particular page, say the home page, I'm only going to recompile that particular module. And that also cuts down on a lot of time. And then lastly, one of the things that we found useful, since we were trying to do performance testing to figure out where our bottlenecks were and what was taking all the time, in hosted mode, you have system.out and you've got GWT log. Well, that works great, but hosted mode doesn't really reflect actual performance that you're going to get in a real browser. So what we've done is we've created something that's very simple, sort of works like a console in an actual browser. And basically all we do is we open up our application in a frame, where we have a frame that's got our application and another empty frame, and simply by calling document.write on that other frame, we can output anything we want to that particular frame. So I can now embed document.write calls wherever I want in my application, and it's just going to output those in a console-style type of output. And it's a pretty simple way to get that in any application. So that pretty much wraps up our talk. I think we have plenty of time for some questions. I think after this, we're going to go to the fireside chat.
Yep, and then we're going to be in the demo area if anyone wants to talk to us afterwards, both this evening until the After Dark thing and probably sometime tomorrow. So thanks for coming along. And if you want to ask questions, please step up to the mics. Thank you.
Hi. I just wanted to ask, you know the layout or the widget that you use to actually hold those activity items? Did you have to dig into the DOM to do that, or is that standard GWT?
The thing that generated the HTML?
No, the actual layout that holds the activity items and that moves very intelligently when you create more.
Oh, on the map view where you add more stuff and
yeah.
No, we had to do that ourselves.
Okay, thanks.
Well, oh dear. Okay. Yes.
Did you ever consider licensing some of your GWT infrastructure? Or
actually, no. I mean, not until you asked that. No. I mean, sorry. No. I mean, we like I said, we sort of we started with the HTML and Flash version, then we went to Dojo, and so some of the stuff that you see we sort of initially did in Dojo, like the all the stuff with as you add more milestones, they all shrink. And then we redid it in GWT. Now, I don't know how genericized it is, how really useful it would be to anybody else. I mean, we can certainly consider we'd probably open source the thing at that point. I mean, it's pretty.
Does the GWT licensing that Google provides, does that offer the businesses the ability to put commercial extensions on GWT? Do you know?
I don't honestly know, no.
Is it all Apache 2, or is some of it?
Yeah.
Everything?
Yeah.
When you decided to adopt GWT and move away from Dojo, what type of, culture shift did you see in the development from client side to the server side development, and how?
We're basically a Java shop. So Lombardi's other product is a thing called Teamworks, which is an enterprise J2EE app. So the guys working on Blueprint come mostly from a Java background. Now, we got Dojo to work pretty well because, it's not rocket science. Certainly to get the fancy JavaScript stuff to work, you need to understand it, but it's doable. Switching to GWT, what do you see? We get to use the much better tooling is the big thing. It's fantastic to be able to use IntelliJ or even Eclipse if you have to, or NetBeans. So it's true. So we really like the tooling. It fits in well with the rest of our development. And tools like find bugs and all that other stuff from the Java tool, like toolchain, really works well with GWT. We were never really. I don't know if we ever really had a JavaScript development culture. So it really fit right in. It was much easier actually for us to develop this way because I think we really, we like the static typing we get with Java. We don't miss the dynamic stuff you can do with JavaScript. We like the tooling. Refactoring. I can't imagine working on something the size of this in JavaScript and not being able to rename a method. It's just unbelievable. How would you do that? I want to extract it in a class. I want to do all this stuff, and it's like a mouse click away in a decent IDE, but it's a hell of a lot of work in Emacs.
Yeah, I think we found that knowing the HTML DOM is actually more important than understanding JavaScript.
For GWT, yes.
To use GWT. Because ultimately, that's what GWT generates, is it generates HTML. And if you don't understand what that HTML is and how it looks, then you don't have a prayer.
And certainly, we never have, the Java to JavaScript compilation is absolutely bulletproof, as far as we've found. The thing that you'd think would be really difficult to actually get to work, hey, we're going to convert this Java into JavaScript, never a problem. It's always perfect. You never have to look at the generated JavaScript and think, well, is this actually doing what I want? Is there a defect in there? That's all fine. We just program at the Java level. There's a few bits where we call some native methods. We're trying to get rid of all of those because it's far easier to debug hosted mode if you have absolutely none of that stuff in there. It's great.
And as a follow-up, what are the interactions with the style people, or the people who do the CSS and all the layout and the other layout? How well did that work when you switched to GWT?
Well, we do have a UI designer. I don't think our process is quite where we want it to be, but he can hand off HTML to us, so he can provide us with HTML mockups. And since that's what GWT produces, we just need to make sure that GWT generates that same level of HTML. We don't have a UI designer that is capable of doing Java programming, so he doesn't actually get into the code. He just provides us with mockups or pictures, and we just write the GWT code that generates.
Well, there is the bit about avoiding tables. So it's much better if you can have a div-based layout with CSS to do the styling, because then you can have the designers fiddle with the CSS. Whereas if you've got tables involved, it's all a bit more dodgy, especially cross-browser. And the thing is, for some of that, you need to know if you pick widget X from GWT, you're going to get a table. If you pick widget Y, you're going to get a div. And that sort of stuff can get a bit hairy. You end up implementing something that's really nice. You've got tabs across the top, and that's tables. And now when I'm trying to get it work in Firefox 2 and IE and on Windows and on Mac, it's a bit more tricky than we'd like.
Yeah.
Thanks.
Okay.
I was just curious how you implemented the server side, and if GWT affected any of the decisions in your architecture.
Probably the biggest decision that affected is we couldn't use any Java 1.5 code.
Oh, well, you can now.
Well,
So in terms of the initial, the server side is separate from the front end, or the server side bit of the client code that runs on the server?
let me say it wrong. The stuff that runs on the servers, did you decide to use Spring or Hibernate, and how did that relate to GWT, or what did you decide to do?
There were no extra considerations from using GWT that made us go one way or another. I mean, the initial using Jetty because we wanted to use continuations was basically an Ajax thing, not a GWT thing. And we've not had we've not really had to make any server-side changes to support the fact that we've got GWT. Now, the Teamworks people at Lombardi do have some issues because they have like data transfer objects in Java 5, so they got generics and stuff in it. And then now at the moment they're using GWT 1.4, so they've got to have separate versions and they have to have code to move the stuff across just to get the RPC to work. With the GWT 1.5, that should all go away. But we've certainly not built a GWT backend. I mean, it's all just standard code, and there's a very thin layer of servlet that does the RPC side. And after that, you can't tell what the UI actually is.
Cool, thank you.
I'm from the GWT team, and I just wanted to really compliment you on how much well, obviously the product itself is awesome, but I say that every time I'm at a microphone. But no, that you took the approach of the idea that user experience was non-negotiable.
Yes.
What was negotiable is how you chose to implement it. And I'd love to hear you go through that because that's exactly what we try to encourage people to do with GWT. We want to give you so much leverage that, okay, widgets don't work great for you out of the box in this particular use case. So that makes sense. So how does the programming model work for you when you start to go off the beaten path? Does it still work well? We want to make sure it's powerful enough that it does. And I just really applaud you for focusing on the user experience. And that's exactly, you guys are the perfect example of the kind of smart people we're trying to give a lot of leverage to. So thank you very much.
No, thank you. It's a great toolkit. It really is fantastic. We would certainly not be where we were today if we were doing this stuff in JavaScript. As far as we were concerned, it would be impossible.
Yeah, I would definitely like to say that there's almost no downside to using GWT. I think, or maybe only no downside at all. If you've decided to implement a Ajax type application that's JavaScript in any way, whether it's Dojo or any other toolkit, if it's going to be JavaScript, it should be GWT, as far as I'm concerned. The only slight disadvantage is it makes it a little more difficult to integrate with a third-party library. So in our case, you saw the Zoom slider that I used. That's actually from the jQuery library. But with GWT, you can actually embed native code right in your Java code, so you can interface with third-party JavaScript libraries. So
yeah, we've got one of our other guys here who's embedded tiny MCE in the latest version of our app, the rich text editor, and that was quite an effort of talking to native code.
So most of our experience basically says there really is no downside. If you're going to build a JavaScript-based application, you should use GWT. I think actually that first slide I had about the tips that had the fast string map is actually a perfect example because we were making use of those things. We were making use of a third-party library, and some other people found out that there was a better way to implement those particular things, and the GWT folks have made a change for it. And so all we have to do is upgrade to the new version of GWT, and our application is just going to suddenly get faster without us having to do anything.
I'm wondering how well GWT integrates with the rest of your process build-wise and say version control-wise. So, for instance, do you have to check in JavaScript to version control?
No,
and
what we do...
Do you use Maven or
yes.
do you fall back on Ant or how well does it integrate with the rest of your process?
So what we do is we use Maven for the general build, but I actually use Ant for the GWT compile and to run the GWT test cases in integration testing. There are some Maven plugins that will do GWT stuff, but when I started doing the build scripts, they weren't where I wanted them to be, so we actually use Ant for that part of the process. We don't check in the generated JavaScript. We do check in, of course, the source, the Java source. It really fits in pretty well. I mean, the only problem we had was with the GWT test case and the fact that as delivered, you can't talk to a server other than the embedded one, but we have a way around that. So.
All right. Thank you very much.
Thank you very much for coming.